Today we're going to talk about Chapter 6, Water and Atmospheric Moisture. Water is a very unique compound. It's colorless, odorless, and tasteless. Pure water rarely occurs in nature because it is a good solvent. Your body contains 70% water, and water is the only substance that occurs as a solid, liquid, and gas. Now, water changes phases in that it changes its state through freezing and melting, condensing and evaporating, and depositing and sublimating. When we look at the three states of water, you're very familiar with solid to liquid. If you have ice, it melts to water, or water freezes to ice. You're also very familiar with liquid water evaporating into gas or water vapor, and water vapor condensing into liquid water. This phase change is a little bit different. You have solid ice that sublimates into a gas, or gas water vapor through deposition turns into solid ice. Now when we look at the phase changes of water, 1 gram of ice is also 1 gram of water droplet is also 1 gram of water vapor. Water is not increased or decreased, it just changes state. The mass stays the same. Humidity refers to the water vapor in the air. Humidity is primarily a function of the air temperature and the water vapor temperature. So when we talk about humidity, we talk about relative humidity, which is the actual water vapor in the air divided by the maximum water vapor possible in the air at that temperature times 100%. So when we look at a maximum specific humidity, you're looking at the humidity based on how much water can be in a parcel of air. So the warmer the air, the more water can be absorbed in it in a gas-formed state. The colder it gets, the less water can be in the air. So saturation and dew point temperature, as the relative humidity is at 100%, your air is at saturation, and the water will come out of the air at a relative humidity of 100%. So this diagram kind of explains it a little bit better. You have water vapor at 5 a.m. The water vapor is the same size all day long, from 5 to 11 to 5 o'clock in the evening. The difference is the temperature of the air parcel is different, and the warmer the temperature of the air parcel is, the less relative humidity there is. So every day we have these daily humidity patterns where the humidity fluctuates in a direct correlation to the temperature. So at the highest temperature, you have the lowest relative humidity. So atmospheric stability. Stability refers to the tendency of an air parcel to remain in place or change vertical position by ascending, going up, or descending, going down. An air parcel is stable if it resists displacement upward, or when disturbed tends to return to its starting place. An air parcel is unstable if it continues to rise until it reaches an altitude where the surrounding air has a density and temperature similar to its own. And adiabatic rates are the heating and cooling that occurs because of compression or expansion of an air parcel caused by changes in altitude. Rising air always expands and cools. Sinking air always compresses and warms. Here's a diagram that shows this. As an air mass rises, the temperature will decrease in the lower air pressure. As an air mass is sinking, it will compress and warm. And that's the adiabatic cooling and warming system that you see in rising and falling air masses. So clouds and fog. A cloud is a group of water droplets and ice crystals. Fog is simply a low altitude cloud. Warm clouds are above 0 degrees Celsius, and cold clouds can be below negative 40 degrees Celsius. Now, fog is a cloud layer on the ground. It's caused by warm, moist air next to the ground being cooled to the dew point temperature. Now, moisture in the air can be in forms of droplets or raindrops. Cloud droplets form in the clouds and they attract to each other and create a raindrop. And there's 4 cloud types that are classified by how high those clouds are. Low clouds are up to 2,000 meters. Middle clouds are 2,000 to 6,000 meters. High clouds are 6,000 to 13,000 meters. And vertically developed clouds are from the surface to 13,000 meters. 3 cloud types are also classified by shape. Cirriform, or hair-like or feathery. Stratiform, or flat and layered. And cumuliform, or dense and heavy clouds. Here's a diagram of many of the different types of clouds that we see. You have your cirrostratus and your cirrus clouds, which are very, very high, wafting, thin clouds. There's 2 pictures here. Your cumulonimbus clouds are going to be your huge thunderstorms that are anvil-shaped at the top, your big puffy ones. Your cumulus clouds are much smaller. They're not as high and aren't producing rain that you see. So our cumulonimbus clouds are the thunderheads that you will see when a big thunderstorm comes through. And these are very, very high clouds, and the higher they go, the stronger the thunderstorm. Now, precipitation or rain occurs when water droplets or ice crystals become large enough to fall due to gravity. In warm clouds, this happens because all of these cloud droplets collide into each other and become bigger and bigger until they're too heavy to remain aloft. Remember, a warm cloud is a cloud that's over the freezing mark, so it's water all the way through the atmosphere. In cold cloud, you're below the freezing point, so your water vapor is actually going to be an ice crystal up in the air. And as this ice crystal continues to grow, it becomes too heavy. So a cold cloud is always going to start as snow up in the air. And then as it falls, if it goes through a layer that is warm enough to melt the snow, it falls as rain. You can also have a cold cloud that falls as snow and it never gets above 32 degrees Fahrenheit, so you get your snow. Freezing rain is when it falls as snow, then melts into rain, but remains at 32 degrees Fahrenheit right at the freezing level, so as it hits things that are cold on the ground, it freezes on contact. And sleet and ice is snow that falls, melts into rain, goes back into cooler surface level temperatures, and freezes completely and falls as ice droplets.